AB Calculus Note Card 34, Mean Value Theorem. This is the 34th video lesson in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District, who developed this note card system. Mean Value Theorem. If f is continuous on the interval from a to b, and with these brackets, that means we call that a closed interval, and differentiable on the open interval, a to b, and this time we have our interval described with parentheses. There exists a number c in the coordinate and the interval between a and b such that f prime of c equals f of b minus f of a over b minus a. And you might remember from earlier lessons that this value on the right is what we call the average rate of change. And this f prime of c is going at value of x equals c is an instantaneous rate of change, which we abbreviate as IROC. And verbally it says where the instantaneous rate of change, again, where the instantaneous rate of change is equal to the average rate of change. And graphically, it says where the tangent line is parallel to the secant line, and I drew a little graph in advance here. And we have a closed interval between a and b, so if we make a secant line here, okay, that's not so bad, a little off, but anyway, the slope of the secant line is equal to the average rate of change. And if the function is continuous and differentiable, there is going to be a point, I'm making a point here, on the curve of f of x, that's this curve up here, where at a certain x value c, there's going to be a line, a tangent line, which is parallel to the secant line. So that's going to be, in this case, our slope is going to be equal, we call this instantaneous rate change. So IROC equals AROC. And there is a four-step process, and Stacy didn't include this as she does normally, so I'm going to put down what the steps usually are for the problem. The first thing is going to be find your average rate of change on interval from a to b, okay? A closed interval. Second, we're going to find f prime of x for the function. Okay, now this is assuming in advance that we do have continuity and differentiability. We assess that first before going through the four-step process. Third step is set AROC to say AROC that you found here equal to f prime of x. And the last step is solve for x. And when you solve for x, you have the value of c. So we're going to put this into practice in a couple of problems here. The first one, free response problem. Let f be the function given by f of x equals x cubed minus 7x plus 6. Find the number c that satisfies the conclusion of the mean value theorem for f on the closed interval from 1 to 3. So I'm going to call 1 a and 3 b. And so the first step is to find the average rate of change. So we say AROC is equal to f of b minus f of a over b minus a. And in this instance, we have, let's go find f of b. I'm going to write this down here. F of 3 is equal to 3 cubed minus 7 times 3 plus 6. And that's going to be 27 minus 21, which is 6 plus 6, or 12. So what that's going to be is f of b is 12 minus f of a, and so f of 1 is equal to 1 cubed minus 7 times 1 plus 6. Well, that's going to end up being 7 minus 7, or 0. So 12 minus 0 over 3 minus 1. And that's going to be simplified to, working to the right here, 12 over 2, or 6. So that is our AROC, our average rate of change. Next, step 2 is find f prime of x. Well, f prime of x is equal to 3x squared minus 7. That's it. Third step is set f prime of x equal to AROC. So I'm going to take this f prime of x over here, 6, and move it over here in place of f prime of x. And then we will have an equation. So we have 6 is equal to 3x squared minus 7. And then the last step is going to be solving for x. So if we add 7 to both sides, we have 13 is equal to 3x squared. And so dividing by 3, x squared is equal to 13 thirds. And then taking the square root of both sides, we have x is going to be equal to plus or minus square root of 13 thirds. And because of the restriction, because of the closed interval from 1 to 3, we know that x really is limited to just the positive here. So we have the square root of 13 thirds. And that's going to be, so we say c, the value of c, is equal to square root of 13 thirds. And the last thing I want to do is just sort of think to see if this answer makes sense. Let's see, 13 divided by 3 is, 12 divided by 3 is 4. And so 13 divided by 3 is a little greater than 4. And so square root of a number a little greater than 4 is a little greater than 2, which is going to be within this closed interval here. Okay? Next problem. And this is a calculator problem from the AP test. Let f be the function defined by f of x equals x ln x, or natural logarithm of x. What is value c for which the instantaneous rate of change of f at x equals c is the same as the average rate of change of f over the closed interval from 1 to 4? Well, the first step is find what our average rate of change is. So we have AROC is equal to f of b minus f of a over b minus a. And again, we have a is equal to 1 and b is equal to 4. So first thing I'm going to do is find f of 1. Well, f of 1 is equal to, we replace x with 1, and we have 1 plus ln x. Or 1 plus ln 1 is really what I want to say, right? And the ln, natural logarithm of 1, e to the power of what equals 1, e to the power of 0. So f of 1 is equal to 1. So now f of 4 is equal to 4 plus natural logarithm of 4. So we have f of b. That's as simple as we can make it. So I'm just going to work below here just to give more room. So AROC is equal to f of b. So we have 4 plus natural logarithm of 4 minus f of a over b minus a. So we're going to get 4 minus 1 is 3. So we're going to get 3 plus natural logarithm of 4 over 3. And that's going to simplify to 1. 3 over 3 is 1 plus the natural logarithm of 4 over 3. And what we can do is further simplify. We have 1 plus, if we take 1/3, I'll just write this ln x over 3 is going to be equal to the cube root of x. So using this principle, we're going to have a natural logarithm of the cube root of 4. So that's going to be what our average rate of change is. Next, we're going to find f prime of x. So f prime of x is equal to the derivative of x is 1, and the derivative of ln x is the derivative of x over the original x. So that's it. So now we can take this 1, step 3, we'll take this 1 plus the natural logarithm of the cube root of 4 and set that in place of f prime of x. So we say 1 plus natural logarithm of cube root of 4 is equal to 1 plus 1 over x. And then if we subtract out 1 from both sides of the equation, 1 and 1 cancel each other. So we have the natural logarithm of the cube root of 4 is equal to 1 over x. And so essentially the reciprocal of 1 over x is x, and that's going to be equal to 1 over natural logarithm of cube root of 4. Now, and so that's going to be our answer. Now, it so happens, it says this is a calculator problem, and the best I can figure, we have a correct answer here, is that in the original AP test, the answer choices were in decimalized form, where you'd actually have to calculate this and pick a decimalized answer that would be equivalent to this. So those are the problems we're going to work out for demonstrating the use of the mean value theorem, the 4 steps, and conceptually what it is. Good luck, and thanks for viewing.